For this problem, we're trying to create as many triangles using these 11 points. And for A and B, we are trying to solve it using two different methods. And for C, we're stating a binomial identity and generalizing it using M and N. For A, I started with picking 1 point from the left 4, excluding the corner point, and 2 points from the bottom 6 to form a triangle like this, or like if it's the point, or like this. And the amount of combinations there are is 4 choose 1 times 6 choose 2, because you're choosing any of these 1 from these 4 points, and you're choosing any 2 points from these 6. And you're multiplying because it's and. And then the second way to form triangles is choosing 2 from the left and 1 from the bottom. Basically the inverse of what we did at the beginning. And then the third triangle we can form using this method is a right triangle, using any 1 point from these 4 and any 1 point from these 6 in the corner block to form a right triangle like this, or like this, just choosing any 1 point from here and 1 point from here and then using the corner block. And we're adding all these because it's either this, or this to form a triangle. And if we add it all up, we'll get a total of 120 triangles. For the second method, we start by choosing any 3 points from all 11 vertices. 11 choose 3. But the problem with this method is that we would create triangles that would be on a straight line, which would be a degenerate triangle, which is not allowed. And to take those out, we would need to subtract all the combinations or possible triangles from created that are in a straight line. So the first way is, or the first one we delete is on the bottom, where we choose 3 points from any of these 7. Because if you choose any 3 points from the 7, you would create a line, and then we would subtract those to take it out. And then this is choosing any from the left 5 that would also create a straight line. And we solve all this, we would get the same thing of 120 triangles. And we would get the binomial identity for C, this, which is basically A equals B, because A and B are the solutions to the same problem. So that's why you can say they're equal. And we can prove this using the variables M and N. For answer A, or answer 1, it's the same thing as what we did for A, but in a variable form. And it's just to generalize this for like however long we can make it. It's the same thing using points from 1 point from here and 2 point from here, no matter how long. And or the second part is 2 point from here and 1 point here, and the third part is a right triangle. And it's the same thing. It's just one solution to create a triangle. And answer 2 is the same as B, where you are choosing all the points, no matter how many points there are, and you're choosing 3 from all those points to create a triangle. and these two are the same as this, just try and delete the straight lines. Because both of these are answers to the same question, they can be called equal, which would get this final expression.